Well, hey there. Welcome back to Area and Perimeter Show. Yay, I'm your host, Area and Perimeter Talker person. Yay, Area and Perimeter. We're continuing to move along in this journey of understanding right area and perimeter, the difference of them, how we solve each one. And today we're going to start kind of looking at a fun little skill that comes along where often you're being asked to like think about how these two can be related within the same shape. And one of those classic examples is a lot of times they'll say, hey, create two, like create two, let's go with like a polygon or a quadrilateral really, because we've been really focusing just on squares and rectangles, but create two polygons that have the same area, but a different perimeter. Okay. So again, we're pulling this out to look at it and think about, well, how would we solve a problem like this? Like what would happen? Because we will be asked these types of questions where it's like, oh, can you create two different polygons that have the same area, but a different perimeter? Or can you create two polygons that have the same perimeter, but different areas? Can you create one polygon that the area and the perimeter are exactly the same? And we'll kind of look at all of those today in this video as we play around with like, well, what does this mean? Right. So if we're thinking about setting up the same area, right? And let's just pop that over into the next. So here, we'll just do here. We want same area, but different perimeter. So if we know we're focusing on area, then we know we're working around multiplication. So one of the things that I like to do thinking about this is really going back to those ideas of finding factors or pairs, factor pairs of numbers. And it's all really trial and error. But if I understand multiplication and I know my factors and I know my factor pairs in something, well, then this is going to make this job go a lot quicker for me, right? And so what's a factor? Maybe that's something we've already forgotten, and that's okay. It happens. We forget things, right? So factors and factor pairs specifically are the two numbers we use to equal a product. So for example, maybe I want the product 8. Well, one way I can get to 8 is 1 times 8, and that means that my factor pairs are 1 and 8. 1 times 8 is 8. But also I can get to 8 another way. I can get to 8 by doing 2 times 4, which would mean then I'd have these factors of 2 and 4. So right away, we could even start with 8 and talk about this exact skill here. We could say, oh, you know what? I could create two different rectangles. Let's start with rectangles that have an area of 8. And they'd have the same space. So let's see. This means here for this one, I have 1 and 8, which then I could just say, okay, well, it's 1 square on this side and then it's 8 here. So let's see, 1 cut in half, halves and half and half, half, half and half. And that would show that I actually have 8 squares, right? Like 1, 2, 3, 4, 5, 6, 7, and 8. So the area of this rectangle is 8. And I don't know, for the sake of this, maybe we'll call them centimeters. And so then if I know that that's one way I get to 8, well, another factor pair of 8 could be 2 times 4, which means this time I'm going to have 4 columns and 2 rows. And again, if I counted those, we'll see 1, 2, 3, 4, 5, 6, 7, 8. So it actually takes up the exact same amount of space. In fact, if again, same unit of measurement, right? If each one of these was the 1 centimeter square, well, this right here, it's going to take 4 across the top and 4 across the bottom for a total of 8. Or in this case, it's going to take an equivalent of just 1 of these centimeter squares, but I have 8 along to the bottom. So actually in this case right here, right away, I found 2 different polygons or 2 different rectangles in this case that have the same area, but the dimensions are different. The measurements are different. So then the next part says, okay, cool. Well, if the areas are the same, are the perimeters different? Well, let's find out. And if so, we've done a great job. And if not, we could try to find something else. Because that's the other part about this is like sometimes you do all this work and you're like, oh, cool. And then you're like, oh, that doesn't work. So I got to try a different number. And that's okay. We tried 8, try something else. But let's see first. I guess I shouldn't just assume. Who knows? But let's look. So if I want to find that, we'll call this A. I'll call this B. If I want to find the area of rectangle A, then I just have 8 plus 1 plus 8 plus 1, because that is the measurement, right, along the outside. So 1 plus 8 plus 1 is 9, 8 plus 1 is 9, 9 plus 9 is 18 centimeters. Okay, so the perimeter of A gets me 18 centimeters. So let's look at B. In B, I got the distance from here to here is 4 units plus 2 units plus 4 more units plus 2 more units. So 4 plus 2 is 6. 4 plus 2 is 6. 6 plus 6 is 12. And voila. I actually didn't even plan it that way. That's crazy. That worked right off the bat, which kind of goes to show that all those directions felt like it was a lot. The reality is just like, oh, cool. Actually, I just have to think about my factor pairs, try out these 2, and then find the perimeter and see if it works. So let's see if we can do that another way, right? The same thing. What we want to do now is we want the same area, but different perimeter. Same area, but different perimeter. In fact, I'm going to keep that on the screen. Same area, different perimeter. Let's actually erase. Normally I just go to another page. I don't know why I have to tell you that. It's very clear I'm erasing. You can see I'm erasing. I don't know why I'm narrating that I'm erasing. So if you remember from this first thing, this first example that I just erased, if you just remembered what I just erased, the first thing I really want to do is focus on the area because I want that to be the same. And to help me do that, again, that's thinking about the factor pairs of a number. I could really just choose any number I want. Let's 12. Let's choose 12. Okay, let's do 12. Right? Like I said, any number I want. So if I think about 12, I do want to think about, well, how do I get to 12? Like what times what equals 12? Well, 2 times 6 equals 12. So that'd be a factor pair of 2 and 6, which would mean if I drew that rectangle, I'd have 6 here and 2 here, and that would get me an area of 12. I guess we'll just go with the units, 12 units squared. And then if I stick with 12, right, what's another way to get to 12? 3 times 4. That's another way to get to 12. So that's a factor pair of 3 and 4. So draw another rectangle, call this 3, call this 4, and the area is 12 units squared. Okay, well, now that works, right? I have 2 different polygons with the same exact area, just with different measurements, because I'm going to need the different measurements to have different perimeters. So let's see if I add these together, whether I get different perimeters. So again, I guess we'll call this A, we'll call this B. So A, the perimeter, oh, I shouldn't say it like that. That's going to look like area. The perimeter of A is going to be 6 plus 2 plus 6 plus 2, which is 16. And the perimeter of B is going to be 4 plus 3 plus 4 plus 3, which is going to be 14. So there we go. Okay, it just worked again. This is pretty convenient. So that's one way to really think about this concept. Like, oh, same area, different perimeter. Cool. What happens there? The next one that we might see could be this challenge where it's actually not 2 different polygons, not 2 different models, but it's one model. And they want us to figure out how to find one that has the same area and the same perimeter. Meaning, how do I take a number, multiply it by another number, get that answer, and then when I take all the outside and add them together, it's the same answer as my area. So let's play with that. So again, I think factor pairs, thinking about the factors would be really helpful to begin with. So, and again, with this, it's so trial and error. You're just like, you try something out and see if it works. And so maybe what I'll do, let's just go with 6. I'm gonna start with 6. So to get to 6, I'd have to do 3 times 2, right? So that'd be 3 by 2. So I'm gonna do that. I'm gonna draw this with 3 units up here. I'm gonna do it this way. We need to model it, and 2 units this way. So that means that my area is 6. Let's just call it inches. So this would be 6 inches squared would be my area. Now, in order to do this correctly, what this now means is if I add all of my sides together for my perimeter, I want the answer to be 6. So let's roll with that. I'm going to have 3 plus 2 plus 3 more plus 2 more. So that's what? 5 and 5, 10. So my perimeter is 10 inches and my area is 6 inches. So this didn't work. And that's okay. Like, okay, I tried. It didn't work. But what I noticed is that my perimeter is larger than my area. So like, what is that going to mean? And that's a question we're always asking ourselves as mathematicians. Like, what's next? Like, I'm not tripping. Okay, I didn't get it right. Right? It's not the end of the world. This doesn't prove that I don't understand math. It doesn't prove that I'm not good at math. It just says, oh, I tried something out and it didn't work because this takes work. So let me see, what else could we try? Well, let's just shift. I like to shift numbers around. So I'm just going to erase this for now. That didn't work. But I'm not going to get rid of all my work. I'm only going to think about half my work. So maybe instead of, I guess I gotta clear out everything here. Okay, instead of making these sides 3, maybe I'll make these 4. Maybe I'll call this 4 inches and this 4 inches, and then keep this as 2. All right, so again, the area then is going to equal 2 times 4. That equals 8 inches squared. And then if I add my perimeter, I need 8. Well, 4 plus 4 is 8 plus 2. So this is already too big. So that didn't work either. Okay. That's okay. I'm not even tripping. Let's bump these up. Let's keep the 4. I like the 4. So I'm going to call this a 3. Okay. So now, again, find my area. 4 times 3 equals 12 inches squared, which means now if I add all this together, I should get 12 if I've done this correctly. Well, 4, right? 4 plus 3 is 7. Plus 4 plus 3 is 14. Oh, I'm close. Oh, okay. I'm not there, but I'm close. I like that. So again, I think I'm going to keep my 4. Notice what I'm doing. I'm just kind of doing trial and error. And this is, again, what we mean. Like, you try something and if it works, cool. If it doesn't, build on it. Like, at this point, I kind of keep sticking with my 4. I don't know why, but it feels good. And I'm just moving around with this piece to kind of change what's happening. So let's see, I had it at 3 and I was really close. So actually, maybe this time I'll bump it up to 4 on each side. Maybe I'll just make this a square. Well, 4 times 4 is 16. And then my perimeter is going to be 4 plus 4 plus 4 plus 4. Wait a minute. Oh my gosh, this works. And I just got an idea about how I could actually do this quicker next time. I'm wondering if you noticed that, like, if you're noticing that relationship, because this actually worked out. I did it this time, same area, same perimeter. And what I'm wondering here is how we think about multiplication and repeated addition, right? That's the same thing. I'm going to end up with the same thing because here, this is 4 groups of 4. And this is 4 4 times or 4 groups of 4. So I wonder if I was asked to do this again. Let's try this again, right? I wonder if I'm asked again to find the same area. Whoa, that was weird. Same area and the same perimeter, right? That question comes up again after all that trial and error. And that's the cool thing. Notice how I learned something from trying it out. What I'm noticing is like, I would have to have the same amount of groups, right? So like, and I don't know, I'm going to test this right now and see if it works. What if we had 3 times 3, 3 groups of 3, right? 3 groups of 3 is going to get me 9. So that would be 3 and 3, which would get me 9 units squared. And then this is actually, when thinking about the perimeter, this is the same thing as 3 times. Oh, but I have 4 sides. So actually I would need another 3. So maybe my theory didn't. I was thinking for some reason if I had done like 3 times 3, 4 times 4, 5 times 5, those would all work. But actually I guess it doesn't. And that's okay, because again, that's math. Like, that's math. I had an idea. I went with it. Didn't quite work out. I had 4 groups. Oh, wait. It's a 4-sided shape. So it'd have to be 4, because I need 4 sides to add. I wonder if that, oh, wait, okay. See, I have a new theory. I like this. Okay, so what if I did 3 times 4? That would be 12 units squared. And then 3 times 4 is the same thing as 3 plus 3 plus 3 plus 3, which is 12 units squared. Oh, wait, I wonder then, because it's a 4-sided shape, then if I take any number and multiply by 4, if this would work. Because you're going to have to take those same numbers and add them together, and repeated addition and multiplication are the same thing. This is my new theory. Wow, this whole video has gone a completely different way. I really like this though. Okay, so, and I hope what you're seeing out of here is how really this work with area perimeter, when you have to do this kind of stuff, it's all about playing around and figuring it out. So, okay, my theory is then any number times 4, right? Because you're using a 4-sided shape, would give you something that has the same area and the same perimeter. So we can only test that out by just putting in another number. So let's say 6. So let's say that this is 6 times 4. Oh, wait, but that changes these. Well, let's see. Right. Oh, because I mislabeled this. It's not 3, 3, 3, and 3. This is 4, and this is 4. So actually this equals 14. So there we go again. I had this whole theory and I'd actually just made a mistake. And that honestly is what I hope you're really seeing about math. Because that I realized, oh, it's actually not 4 all the way around. It's 6 up here, it's 4 here, it's 4 here, it's 6 here, which that's actually just equals 20. So my perimeter is 20. So I had an idea and I was wrong. That's okay. But I did also use problem solving. Oh, that's what happened. I changed pages on accident. I also did just use problem solving to kind of figure something out. And that's really what we want to do as mathematicians, is really be thinking about what are the skills we know? Well, if I want the same area but different perimeters, if I'm making 2 rectangles, well, maybe I'll use factor pairs to come up with 2 different ways to get to a number. And then if I'm trying to find something with the same area and the same perimeter, well, maybe it's guess and check. Like I thought I had a theory. It didn't work. No, this one didn't work. This one didn't work. That page is weird. This one worked. And that one was more with trial and error. And that's okay. So again, I want to thank you for your time with this and really think about like understanding, like it wasn't really about a skill today. It was about an exploration. It was about trying things out. And if they worked, great. And if they didn't, okay, we just tried something else till we found a solution that did. So with that being said, I appreciate your time with this, and we hope that this, helps you get thinking more about having a flexible mindset and not really worrying about having an answer right away, but actually seeking an answer through trying things out and then trying them again and then trying them again. Ooh, and then thinking you have it and then realizing you don't. So you try it again. And that's okay, because ultimately you're going to get to the right answer if you keep up that positive attitude and that positive work. Until next time, we'll see you later.